kind of realized we are in the midst of our last section for this week, which is substitution rule. And basically, I'm going to look at three situations. The first one I'm just calling common substitutions. And these are the ones that you can pretty much tell what the U-sub's going to be, and they tend to come out pretty smoothly. So you might call them the easy ones, I guess. So if you see something like this, pick the U-sub inside the cosine. If you see if you see an integration that looks like this, pick your substitution, whatever is inside the square root. If you see a fraction, pick the bottom. If you see an e of the ugly, pick the ugly. If you see a big bracket with weird powers like 100, pick the thing inside the brackets. And if you see a very simple 3x in a lot of places, pick the 3x. So those are the kind of ones I think we covered those in ones very similar to those. So I'm just going to let those go. Now, so the ones that are left for today fall into what I'm going to call trig substitutions. All that means is that there's a trig function involved somewhere. And some of these substitutions are still pretty obvious and others are not. So what would be the substitution to use if you wanted to find the integral of cosine 2x?
2x.
Would you agree that that one's pretty straightforward, right?
Yeah.
It's there because it's a trig function. Now, be careful here. Whenever you get a combination of sines and cosines, so that's like question 4 from the homework and question 15 from the homework, for example. Whenever you get a combination of sines and cosines, there's a very good chance that one or both of these will have powers. There is a correct U-sub in these situations, and there is a wrong one. You'll figure out the wrong one pretty quickly. But before I tell you, maybe somebody could tell me, the answer is always going to be a single cosine theta or a single cosine cube theta. In these kind of questions here and here, you'll never have a U-sub that's like sine squared 2 theta or something weird like that. It's just u is sine theta or u is cosine theta. Okay, what do you think the one you should do in question 4 is?
The cosine?
Well, and since I'm going to go, well, then the answer must be
Sine.
the sine. So what's the difference between the two? Well, when you choose a U-sub, there's two things you're looking for. The first one's the obvious one. What's the ugly thing? Because that's typically going to be connected to the U-sub. With trigs, it's a little bit different, but yeah. And the second thing is, what is its derivative? Because very often, won't the U-sub derivative get rid of the other bit? Can you see that a sine will get rid of that cosine? So when you see, oops, almost did a mistake there. When you see a combination of sines and cosines, pick the guy that's got the biggest power, in this case, sine cubed. So sine theta is your U-sub. Let's do that one. So sine cubed, get cosine theta, and for d theta. And I've said, make your substitution that guy. So now we'll do the derivative with respect to theta. We'll do the crossover. And we'll isolate the cosine into d theta by dividing both sides by cosine theta. Okay, so you go over here and you say instead of the sine cubed, you now get u cubed. I'll leave the cosine theta for a minute. I'll replace the d theta by this. And just like magic, our integral turns into that guy. See how smooth it was? Now, add 1 to the power, divide by the new power. and then back to the, in this case, the thetas. So it's going to be 1/4 that guy. So that's how you're going to take care of sine squared cos theta, cos cubed sine theta, right? Anything with some sines and cosines mixed and matched. Right, let's jump to 15 then. What would the u sub in 15 be then?
It'd be cosine.
Okay. Pick the one that's got the biggest power. Your unit cosine definitely is bigger power, right? There are 4 of them. And it would look very like that question. I think there'll be a negative involved in it. Don't be caught off by, I think that's question 12. I can't read the one right. What's the u sub in secant squared 4 theta? It's a straightforward one. It's not actually anything that weird.
Tangent theta?
Well, that's going to be eventually the answer, Ismail, but what's the u sub before we get there?
I was looking at the wrong question.
Oh, okay, that doesn't help. That's probably one of these ones, right? What about this one, this question here? U sub for this guy here.
Isn't it 4 theta?
Well, since you're all posing at that one, maybe I should do it. You're never sure what questions are going to catch students. There's this guy. There's a 4 theta. Well, if you differentiate with respect to theta, you just get a 4. You do the crossover. You get that. And divide both sides by 4 to isolate d theta. You get that. This fella becomes secant squared u multiplied by 1/4 du. And that ends up looking like this guy then. Now we'll bring that tan thing that you wanted, Ismail, right? That's tan. So you get 1/4 tangent, and then you replace the u, back with the 4 theta. Which you could do, that's not that ugly. I mean, as far as integrations go, there wasn't too much happening there. Now, the one that you were probably reading.
Can I see that real quick again?
Sure. Okay, while you're doing that, let's look at this one. Question 23. What u sub should you use here? Now, this time it's a combination of secants and tan. So we have to think not just who the u sub is, but what it would get rid of.
I got it.
You got it? Okay. When you've got a secant tan, right, like we have here, your answer is either secant theta or tan theta, right? That's all you're going to pick. You got a 50-50 chance of guessing. If you pick the wrong one about 3 lines into your working, you'll know it's the wrong one, right? Nothing will work, it'll just look messy. But it's much better if you can get it first time. What do you think the u sub in question 23 is?
Tangent.
That could be a lucky guess, but it's correct. And it could be because you figured something out. What's good about tangent as a u sub? Or another way of saying that, what's the derivative of tangent theta?
Secant squared of theta.
I'm going to get rid of that guy.
Yeah.
That's why it's picked. Do you know the derivative of secant theta is secant tan? Can you see that's probably not going to work well in this question? But, you know, you take each one as it comes. You lost signal? Okay, so we had this fella. Here is the u sub I'm going to use. And eventually we find out what d theta is, which is this. So we now go into substitution stage. I'm going to write secant squared theta. Tan cubed theta becomes u cubed, and d theta becomes this guy. You know that you've picked a good u sub by the time you get to the third line. Would you agree that is a good place to be, right? Your integral is now turned into a nice thing. If you got to this line here and there was a tan theta left over, or a secant theta line, something left over, right? Something with a theta in it, that's a good sign that you probably chose the wrong u sub. You're getting the abbreviated version of this one. Power rule. And then return back to theta. So if you ever see an integral involving secants and tans, as we do here, then your u sub is either going to be the secant or the tan. If you ever see a combination of sines and cosines, then your u sub is going to be the sine or it's going to be the cosine, depends on the question. Okay. What would the u sub be in 25?
Would it be the inverse tangent?
It would indeed. What made you pick that one?
Well, because if it had been e to the inverse tangent, that would have been the u, I think.
Okay. So your brain was saying, that looks like the ugliest thing in the shop, so I'll buy that one. And that'll probably be my u sub, right? I don't think that's a mathematical term, but you know what I mean. Something that looks really bad is probably going to be the u sub. Yeah, that's a good strategy. Let's just take this one through. You're going to get, as you can imagine, because I had a lot to do, the speeded up version. So if you can't write fast, don't even try. What I suggest you do instead is just watch this video. Okay, after a bit of work, we've isolated the dx, so this becomes 2. That ugly guy becomes that fella. We're going to have a 1 plus x squared, and the dx gets replaced almost like magic, isn't it? Do you see why on the third line I am comfortable that I picked the right u sub? Can you see why when you get to this line, you know you've went the right road, right? You've done the right thing. Quick version, antiderivative, convert back to original. That's how it works. Okay, there's one last one of these, and then we go on to the third and final situation, which is, by the way, going to be the hardest of the three. What u sub would you do in question 26, which is this one?
Would it be
Secant?
I hear secant, and the other choice.
tangents?
And which one of those two is going to, at the end of the day, come out good?
Tangent's gonna derive into secant squared of theta. So those two will cancel out.
So you're committing yourself to the tangent, right?
Yes.
Good, because that's the right one. Okay, let me show you what it looks like when you pick the wrong one, because I can tell you right now, there are going to be some situations where it's just so unusual, right? You've never seen one like it before, and you're kind of working in the dark a little bit. You know it's probably secant theta, or it's probably going to be tan theta, right? You can at least make that assumption, but you don't always get the right one. That one will work, so I'm not going to do that one. Let's do secant theta and show you how to recognize when you've picked a wrong one. Well, when you differentiate with respect to theta. Hopefully you can tell me, what's the derivative of secant theta? That's got some cobwebs going. What's the derivative of secant theta?
Tangent.
Nope, but
No.
part of it is a tangent.
Oh, isn't it like secant tangent?
Correct. You really need to brush up on your derivatives here. Otherwise, you're going to be spending half your time looking up things because you don't know them. And that just tends to slow down the whole, not just the process of doing it, but the whole thought process, right? Getting your mind, you know, A, B, C, D. You're going A, I'm going to have to look for some stuff. Oh, I found it. Okay, I put it in now. What's B again? You know, you've kind of lost the flow. So it's much better if you just know it. Okay, derivative is secant, secant tan. Derivative of tan, secant squared, right? You know, the standard derivatives. Now, when you do this fella, you can then separate, right, by dividing by that guy, and you can isolate the d theta. Well, let's see what happens here. 8 secant squared becomes 8u squared. Can't do anything with tan theta because there's nothing here that says tangent. The d theta becomes 1 over secant theta tan theta du. Right, third line coming up. 8u squared, a secant theta, a tan squared theta du. Can you see what the heck is that? Can you see why you're wrong? Can you see the u sub does not get you out of trouble? In fact, doesn't that integral, I mean, it's just weird, isn't it? It's full of u's and some orphan thetas left over. That's a good sign that you've picked the wrong one. And you're going to pick the wrong one. I'll pick the wrong one when I do them as well. But at least I know to stop when I get to line 3. Okay, if it wasn't secant, who, you know, if it's not secant, who is it, right? And then, oh, try tangent. Can you trust me, tangent works. You get 8 over u, and that becomes 8 natural log of u. And that is the end of that group. Which now brings us if I don't get through all these, chances are I won't. I suggest strongly that you look at the other video that I'll be putting in its place. I'll be putting this one up to where we've got, but I've got another Calc 2 class that don't have the interruption of the power supply, and they will get through these, or at least ones like this, and you can pick those ones up. Now that I've said that, I think all I need to do is edit it and add on the ones I didn't get. Right, that's probably better. It's all about u subs. And the reason I picked these is that they're ugly, they're special cases, there's something about them that's not normal, whatever way you want to phrase it. Right. Let's look at this one. Picking the u sub is not a problem. There's really probably only one candidate that would make any sense at all in this question. Would you agree? And the only u sub is when you got a fraction, pick the guy in the bottom. So that's not what the problem is. Let's show you what it looks like when you try and do the question. Starts off like a very straightforward, nothing to see here kind of question. There's my u sub. I'll differentiate with respect to t. Nothing too weird happens here. I'll do my crossover. Nothing too strange there. And then I'll divide both sides by 8t plus 8. Nothing too out of the ordinary has happened yet. I'll go over here. I have a t plus 1. I'll Put a little bracket around it. I have a u on the bottom. And this fella becomes that guy. And this is where the little special case kicks in. How come the top line didn't kill off the bottom line? That's what it's meant to do, right? Top lines kill off bottom lines, and then you're left with something like 1 over u. But the top line is t plus 1, and the bottom is 8t plus 8, and they're not the same thing, so I can't cancel them out, and now I'm confused. That's maybe where your brain is.
Can you suck out the 8 from the 8t plus 8 in order to
And-
cancel out the t plus 1s on both sides?
Couldn't have said that better myself. You see? Now we can do the cancels. And you know I like to call these things slightly artificially. 1/8 of 1 over u. That makes it easier to integrate, at least in my mind. And then you switch back. Yeah. So the only little special case here is that sometimes you may have to do something like this, right? Factor out an 8 or something to make the cancel happen. Okay. Question 21 is only a special case because it's just ugly. There's nothing really that awkward about it, but I felt it belonged here anyway. What would the u sub in question 21 be? Don't have a lot of choices, do you, when you look at it?
Would it be natural log of x?
It would. Okay, let's show you what that one looks like then. Since there was a lot of pausing, it wasn't that clear to you yet that that would be a good use of. So we're going to choose the natural log of x as our substitution. I'm going to differentiate with respect to x. I'm going to do the crossover. Hey, we already have isolated dx, so this one only needs 3 lines of working. Well, let's see what we get. This fella becomes u to the 8. Leave that guy alone. Replace the dx by x du, and lo and behold, we nailed it, didn't we? See by the third line, everything looks good. Add 1 to the power, divide by the new power, and then convert back to the x's. That is the end of that. Not as bad as you thought it might have been when you looked at it at the beginning. It didn't harm here, but can you imagine I had some other ugly thing, and I picked my u sub, and I got to this line, and can just for a minute imagine that the line said something like this. Wouldn't you be worried? Right. You don't want to see, by the time you get to here, and maybe it's the 4th line, depends on your algebra, you only want to see u's when you get to here, agreed? You only want to have things with u's, you're on the right track. Let's look at this one, a trig one. And I picked, God, what's that? 45. Can't read my own writing. 45 plus cos squared x dx. What do you think the u sub is going to be in question 31? You know, if you pick the wrong one, I'll just say, well, that one's a good idea, but it ain't working. And can you trust me that by the third line, it ain't happening? We've got to be able to look at these, because I'm not going to be with you when you do your homework and we do a question I've not covered, right? Or in 2 weeks from now, you've got an integral like that, and you're going to say, well, I don't know how to do that. I didn't pay attention the first time. What we're going to get as a use up here.
Cosine?
Oh, interesting. If that in the top had been sine x, I would have said, yeah, I'd probably have picked that too. Do you notice that the top says sine of 2x? That's
Oh, I
not
did
going to
not
work.
notice that.
Yeah, but that's fine. But see, you're thinking. I like thinking. Okay, so go for another choice now.
The whole denominator.
What made you think of that? By the way, it's right.
There's too much going on.
Yeah. So can you think of this as being a fraction, which it is? Isn't one of the rules the whole thing on the bottom? You know, when you get fraction, pick the guy on the bottom. Is it because you see sines and coses and squares and things, you start thinking, but you had a rule earlier on when there's sines and cosines, you only pick a sine and cosine. Do you see that sometimes rules interfere with each other? Because a thing can be both at the same time, but only one of the rules works, right? So in this case, it's the rule, everything on the bottom. So if you differentiate this guy with respect to x, now this will definitely get the cobwebs going. If you want to differentiate cos squared, isn't cos squared actually cosine x with a bracket round in a square? Let me do that at sec. To differentiate this, you have to do the chain rule, which means you have to remember that that's really what it is. That's just a convenience. So when you differentiate this guy, it's a power rule. It's something squared. So it's 2 lots of cosine x, finishing with the derivative of cosine x, which is negative sine x, which means the derivative is actually that guy. Are you comfortable with that? Now I'm going to bring something in that you don't normally do, but Trig can do this to you. Forget about the negative for a minute. Do you know an identity for 2 sine x cosine x? What's 2 sine x cosine x the same thing as?
That's the double angle formula for sine 2x.
And that's the guy I'm going to use. So du by dx is negative the sine of 2x, right? That's the working for where that came from. If you do the crossover, and then finally you isolate. Isn't that going to play well with this one? Can you see the sine 2x's are going to kill each other off in a few minutes? So here goes. Sine of 2x over u times 1 over negative, I don't know where that 2 came from, negative sine of 2x du, and you end up with that guy. And that guy integrates to there, and then you switch back to the x's. We are getting to the thinking ones, right? The thinking person's puzzles. Each one of the guys that we've got left has something going on that makes them a little bit different than the typical one. So if I clear your mind and approach this one with a fresh look. This one breaks every rule. None of the basic rules that we usually use work here. So I'll tell you who's not the right answer. 1 plus x to the 20 is not the right u sub, doesn't work. X to the 9 is not the u sub, doesn't work. X is never the u sub, doesn't work. X to the 20 on its own is not the right u sub, it doesn't work. That's all the ones that don't work, which are pretty much covered everything that you would typically do in this situation. So now you have to think about, well, what is left? What have I not tried? What would be a good u sub in this one? Don't mind being wrong. I don't mind people being wrong. I like people thinking. And that's how you learn. You think and say, oh, I wonder if that worked. Okay, it didn't, but I'll remember that next time. What is it?
Whole denominator.
Could be. A lot of questions it would be, but not this time.
Is it 1 over the denominator?
Oh, interesting. Never thought of one. No, but I like your thinking. Okay, here goes. Where the heck did that come from, you should be thinking? There isn't even an x to the 10 anywhere. I mean, you brought that one out of mid-air. Well, let's see. What's special about x to the 10? Well, when you differentiate it, won't you get rid of that x to the 9? That's what's special about it. So let's go through the process then. If you differentiate with respect to x, you get 10x to the 9. You do your crossover. And then divide both sides by 10x to the 9. And that's you. You've isolated the dx. Now, what you should do in situations like this is, now that you've seen that one, won't you be more ready to do another one like it when it happens in the future? You're going to think, oh God, I remember seeing something like that and it wasn't any of the obvious ones. Oh, it was x to the 10 or whatever half of that is. Right, so what do we have? We have an x to the 9. We've got a problem with this, which I'll fix in a minute. We have a 1 over 10x to the 9, and we have a du. So we have the problem of that guy having to turn into a u of some sort. Well, isn't that the same as x to the 10 squared? So won't that become 1 plus u squared? Are you happy about how that denominator can be written in terms of u as 1 plus u squared? Which means that we can now do our little cancel thing, and I'm going to call it 1/10 1 plus u squared du. Ah, I know what this fella is. What's the antiderivative of 1 over 1 plus u squared?
It's one of the trigonometries, right? Was it
It is.
sine?
Nope, keep going.
I think it was
Inverse cosine?
Keep going, you're closer.
inverse tangent.
That's the one. That guy, antiderivative is inverse tangent. And then you return back to the original. Now, maybe it's early in the morning and our brains aren't working, but we have got to be, I think, otherwise your homework's going to take forever. Because if every time you do this, you have to go hunting for what that is and how you differentiate this and what's the integral of that, it's going to take you twice as long. Try and get up to speed on derivatives of standard ones. Now, if I could find my little guy, which I probably threw away. Yeah, probably did. Yeah. That's unfortunate. Should have kept that. Do you know that table I had with all the standard integrals? Do you know if you read them from right to left, you've now got all the standard derivatives? I mean, that table can be used in both directions. That might be something you want to have a little practice of. Okay, we're getting really close to our end. I've got time to talk through a couple, but that's all. First one that I want to do, and that's probably the only one I want to do because of time. Is, I guess I should add another special. This one is special cases. This one breaks every rule that I've given you, but it doesn't mean that the rules I've given you are wrong. The rules that I've given you will work for 99.9% of the time, and that makes them really useful. But in math, there's always some guy who'll come up and say, hey, try this one. Hey, your rules don't work, do they? And I'm going to say, yeah, okay, you found one. But nonetheless, it doesn't mean I can't find the answer. I just have to fight a little bit harder to get the answer. Now, this question does not look particularly dangerous. And by the way, 35 is very similar. So if I show you this one, you kind of know the general process for 35. So I'm giving you 2 for the price of 1. First question is always the usual question. What is the U sub? Actually, that's the easy bit. This one does not have a weird U sub. Its U sub is actually very simple and obvious. That's not the problem. So what is the U sub?
X plus 4.
Yeah. And see, when you do 35, it will be x squared plus 39. So that is not the problem. So why is this a special case? Well, let's differentiate and find out. If you differentiate this one with respect to x, you get 1. And if you do the crossover, you get that. And what do I have? I have an x, I have a square root of u, and dx just gets replaced by du. Wouldn't that normally be an indication that you've picked the wrong U sub? The reason why, there's an x left over. There shouldn't be any x's left over. Isn't that my usual rule for you've picked the wrong U sub? And 99.9% of the time, it will be because you picked the wrong U sub. But because this is a special case, you haven't picked the wrong U sub. You just have to work with it. The problem I've got is I've got an x left over. And I don't want any x's left over. I only want things with u in it. So now I'm going to have to figure out, is there a way that I can replace the x with u's? And if I write down my substitution, because that's where I should start, do you see that if you subtract 4 from both sides, don't I now have an x? And so what I've now got is a u take away 4 times, I'm going to call this guy, instead of the square root, I'm going to call him the half power. So I now have this line. So you might be saying, well, that's great. You've taken an ugly integral with square roots and you've turned it into another ugly integral with square roots. I'm no better off than I was when I started. But actually, you are better off than you are started. This square root, I know u to half is a square root, is actually doable. What should my next line of algebra look like? What should I do with this?
I'd multiply the u to the 1/2 power by u minus 4. So u to the 3/2 minus 4 times u to the 1/2 power.
Do you all agree on that? That makes sense. Isn't that just ugly power rules with fractions? So add 1 to the power, divide by the new power, add 1 to the power, divide by 3/2 is the same as multiplying by 2/3. That's why we get that. Do some style points on it. And to finish, get back to the x's. Oops. Wasn't that a really weird looking question? But didn't we still use substitution as the main method to solve it? Now, after I've shown you this one, I do not want you to say, but if you go back 20 minutes, you went and said, if you see an X left over, it means you've got the U, you've done the wrong U sub, pick somebody else. Remember I said this sentence, something like that? That's still true. 99.9% of the time, if you see an X or an X squared or a sine X left over, right? Something with X is left over, you've picked the wrong U sub probably. With some very rare exceptions. Can you see this is, what's this? The exception that proves the rule, right? Not all of them do that. And as long as you've got that good mindset, you know, math isn't, oh, let's rephrase this. Integration is an art rather than a science. Calc 1 is mostly a science. In other words, there's rules for differentiation. If you stick to the rules, you can throw anything in and you can differentiate it, can't you? But in integration, there's a little bit of art involved, right? A little bit of skill where there isn't one rule, right? One size fits all. There's like 3 or 4 rules for 3 or 4 different situations. And then here's a couple of guys who break the rule. And the couple of guys who break the rule are just as important, right, as the ones that do the thing, right? Okay, talk through it because I don't have time. Not much to talk through. 35 is very similar to this one. So when you do that homework, think about how we did 24. And the only one that I haven't spoken about is 34. And here is your clue to doing 34. While I'm doing this, you might want to say your name, last name, followed by your first name for attendance. There. Do you notice what I have done to question 34? Do you see I've split it into 2 things? Question 34 is no longer a single question. It's now a special case, right? It's 2. Do you recognize that one as I don't need to do anything because it's a standard integral? And this one, what U sub will you use to solve that fraction? What U sub will you use to solve that fraction?
6x.
Okay, you could try it and it doesn't work. So what will you try next? It's okay if you get it wrong because you know you can
1
try it.
plus 1 plus x squared.
Can you see why that one probably would be a better choice? Isn't
Yeah.
that when you get a fraction, use the guy in the bottom, right? So don't talk yourself out all those little rules that I gave you because 99.9% of the time they work, right? So stop looking at ones and thinking it's a special case because that means you'll end up having to do 2 or 3 things so you get the one that works. And that is us for today. I will see you all on Monday and have fun.